Friday. Happy Science Friday. So today we're going to be talking about electricity. More specifically, we're going to be talking about batteries. So we all have batteries in our house, and batteries power everything. They power your remote control. They power your PlayStation controller. They power so many things. There are different types. There are like the small ones. There are these huge, big ones. There are these kind of like big ones, but smaller than the biggest one. Then there are 9-volt batteries. So batteries power so many things. And today I want to talk about how batteries work. And what we're going to do is we're going to actually be charging a cell phone without plugging it into a wall. So this is like, let's say your power goes out and you want to learn how to do that. You can do that. But I want to talk first about how batteries actually work. So this is my battery, another Picasso drawing. This drawing is also for sale. $3 million. It's a little more expensive because it has colors in it, so just so you know. Okay, so this is my battery here, and a battery operates with what's called an anode and a cathode, okay? So one is positive and one is negative. So there are positive and negative charges, and we see that on a battery, okay? So here's a battery, looks exactly the same. So usually this bumpy part right here, that's this part, that is the positive side, and that's called the cathode. And the way to remember that is because it's spelled with this plus sign right there. So it has a T, so think of the cathode with the plus sign, and then the anode is the other side, okay? So anode, you can think anti, right? Anti means like negative. So think anti for anode. So one is positive and one is negative, all right? And positive and negative, meaning that this side has extra charges and it wants to get to the other side. So when we have our battery here, come around, we actually have our battery. We see that this bumpy side, the cathode side, the positive side, and the negative side. So the positive side has extra electrons that it wants to give away. It's so generous, your cathode is, and it wants to give them away and give it to the anode, okay? So you're thinking, of course, it just goes right over there and gives that to the anode. Not true. That's not what happens, because what we have in the middle is something that we want to actually use that power for, okay? So we want to take that potential energy, because right now it's just there, it's potential. We want to turn that into something, and we're going to create what's called a circuit, okay? So because we have something that we want to power, like let's say a light bulb. You want to power a light bulb, and this is my light bulb. This is like real-time drawing, like Bob Ross. Okay, so this is my light bulb here. Make it look more like a light bulb. Okay, this is my light bulb here. So I want to get the positive and the negative charges. So what a battery actually has is it has, right in the middle there, it has a, get this marker right here, electrolytes. And you're thinking to yourself, oh my gosh, I've heard that term before, electrolytes. That's the stuff that's in Gatorade. Those are the things that I take in order to exercise better. Exactly. So it has electrolytes in the middle, which cause a chemical reaction. All right, so the electrolytes are here. It's a negative charge, and it will not allow this positive charge to cross through. It won't allow it. It repels it back. Okay, and it acts as a buffer to not be able to actually get to the negative from this side, because we want to use that actual stored energy. So what the electrolyte does is says, all right, positive charge, you have to go this way, and then we create a circuit. So we usually have a wire, connects to your light bulb, and goes to the other side, okay? And that's how it's getting to there. So the electrolytes actually push that out. It's the very same thing that happens in your body. You notice when you get a cramp, when you don't drink a lot of water, or you don't have sugar or whatever in your body. So the most common types of electrolytes are sodium, that's salt, potassium. That's why everybody always tells you, like, eat a banana if you're cramping up, or if you're, just kind of run down or tired. It's because you're probably missing electrolytes in your body. And then magnesium. Okay, so these are the most common types of electrolytes. So those of you guys that drink a lot of Gatorade does have electrolytes in it, but it also has a lot of sugar. So when you're looking for a good electrolyte, you want to do this. But this is what your body does. Your body sends a signal to your nerve using electrolytes. It causes a chemical reaction in order to light your nerves up, to get your positive electrons over to the negative side, so that actually causes an electrical reaction, so your nerves fire. Okay? If you don't have those electrolytes, what happens is that they never get to each other in a closed circuit type of way. You don't get what you need, and then your legs cramp up and you seize up. Okay? Cool. So this little cool device is called a multimeter, and it has a positive and negative charge on it, and what it does is it actually measures the amount of power coming out of a battery. So you can use it on something like this D battery right here. And we're gonna set this, and what it actually does is you're going to put it on the side. It's kind of hard to both hold up and do. I'll come in front of the camera. All right, so you're gonna hold this up, and what it does is it actually measures it. So we're gonna put, obviously the red, can you see me? The red on the negative side, boop, and then this one on the positive side, and you can see that it's going to register a charge. And I'll get real close so you can see it while I'm holding it at the same time. Boop, boop. And you can see that it's actually measuring what the voltage is of this battery. So you can see this is 1.4. Usually these batteries are about 1.5, okay? And you can see that on the side what the output is of the battery right there. Oop, this way. Alkaline battery, and on the side, if I turn it, you can see that this is supposed to be a 1.5 volt battery. So this is measuring voltage. Now, if I do something like a 9-volt battery, I'm gonna set this to 9 volts. And this is a really cool tool. You can get this at any hardware store, or you can steal it from an electrician if you know one. Okay, so this is a 9-volt battery, and there are positive and negative ones. This little funky one right here is the negative one. This one is the positive one. So I'm going to take the negative. I'm going to put it here. Boop, maybe. And I'm going to take the positive one. I'm going to put it there, and you can see the measure. See, and it's measuring a little over 9 volts. So I got a little extra one, a little BOGO on this one. Okay. But what I want to do today is show you how you can actually charge your phone using this 9-volt battery. All right, we can't use something like this because it doesn't provide enough voltage. Usually your phone, in order to actually capture that charge, it needs about 5 volts, okay? Now my 9-volt battery is not gonna charge my phone all the way. It needs a lot more than that. I can create more circuits. I can kind of tie these all together just like it does in your house. It creates more voltage, but this 9-volt battery will do a pretty good job. So if you're ever stuck, or if you travel, or if you have some sort of emergency survival kit, what you can do is just put a little 9-volt battery in there, and that if you ever just need like, oh my gosh, I just need like one little charge, you can go ahead and do that. Okay, so what you're gonna need is this little car charger thing. You guys have probably seen these. You can get them for super, super cheap. And on the car charger, you're wondering like, where's the positive and where's the negative? I'm gonna help you out. Little bump, always remember that's the positive side. And this little thing right here, you thought it was just to like, go like this with, or make some sort of weird whatever. This is actually the negative side. So when you actually put it into your car charger, these little negatives here, and this is the positive, are what's reacting, okay? And then I just have, you can use from a ballpoint pen, the little clicky thing, you can use that spring, and you can tie it around the negative. I just took like a little piece of, I think this is, I don't know if you can see this. Yep, so if you look at this, you can see that this is like a paper clip that I just took apart, okay? So what we're gonna do is we're going to take our charger right here, and I have my phone. All right, so I have my charger, and I'm gonna wrap this around the negative. And again, if you have a spring, you can sort of like load the spring around it. So I'm gonna take the negative, and I'm gonna match that to the 9-volt battery. Okay, so I have this, and it's attached to the negative just by piece of metal, and I have my battery. So what you guys need to know is that a battery also has inside of it, it uses zinc, and it uses copper. So copper like in a penny, and then zinc. So a lot of times you'll see like people use like a potato to actually light a light bulb up, or like they try to charge their phone with a lemon or something. What they're actually doing is they're taking 2 different metals, so one that has extra electrons to give. So as long as it's 2 different metals, you can use zinc and copper. They're a little more readily available, so you can, you know, wrap a penny, put it in a potato, and you can take a zinc plated, like an outdoor nail or something that's plated, and you can create your own circuit together. So we're doing the same type of thing here. We're gonna put that on there, and we're gonna wrap it around our negative side. So this little weird hexagon-y shape. Hexagon-y is a new word. Feel free to use it. Copyrighted Miss Aki, 2020. Okay. So we're just gonna wrap that around there, and this metal is gonna act as our conductor. And just to prove that this actually works, I'm gonna come real close, and I'm going to show you. So I have it wrapped all the way around. I'm gonna touch my positive piece to this side, and you can see, look at that, it lights up. So from there, what you can do is you can take your charger. I'm gonna plug my charger into my phone, just like that. And you can see it's not on because it's not plugged into anything. And we're gonna do the same thing. So you can see my phone here, it's not on, doesn't have a charge, and I'm gonna press this to this. The little light's gonna come on so you can see that it's working. See the light? And watch my phone. And now it's charging. So I'll take it off so you can see. Let's unplug and plug. And now you can see that it's charging. So I'll come real close and do it so you can see things. You can see that it is charging right now. Charging, and then if I take this off, no charge, charging. Look at that. And that's how you create a charger from a 9-volt battery. And again, you can't do it with something that's a little bit smaller because this is registering as 9 volts. And it'll just keep charging your phone. So if you ever want to create like a survival pack, you can do that with a 9-volt battery, this little car charging thing, and your charger. And that's it. That's all for Science Friday, guys. I hope you enjoyed that little fun how a battery works. If you want to see more things, you let me know what it is that you want to see, and I'd be happy to experiment for you. Again, happy Friday.